I'm getting over from a little cold. That was a week ago, so I'm not contagious. I'm very glad because not for the presentation mainly, just to learn about my roots. Thank you so much.
Let me, it's not on
Yeah. Apparently, I have royal roots, so more respect, okay? So thanks. We'll continue on that conversation after this. I'm a scientist. I'm a satellite guy. My 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 skill is to interpret satellite imagery with a geophysical background, with climate change and geology, with what's going on in the forestry side, ocean side. Satellite images are very, very big in monitoring globally, and that's my skill. The other thing is that the whole screen?
Yeah.
Okay. So that's my roots, and on the academic side, and working for the Canadian Centre for Remote Sensing. I retired. I spent 30 years there. I retired a couple of years ago, and I've been back and forth to India about 20 times. Has nothing to do with Landslides. Is the Canadian Space Agency and the Indian Space Agency. Like scientists, we do a lot of bilateral publication, refereeing our papers, reading PhD thesis back and forth. It's a scientific community, like all the scientific. There's a lot of integration in science, and India was one of those. So if you work Canadian government in science, you have colleagues in India, and you go back and forth. So when James came, a colleague of mine, a friend, he said, Vern, you want to work with India on landslides? Of course I said yes, yes, yes. Back and forth in India for various reasons. And so the, can I use this arrow to
No,
move it up?
well, you can use that as the pointer, but you'll have to hit the down.
Okay, no, that's
If you
fine.
want to go to the next page.
Yeah, okay.
Yeah.
So the keywords is landslides, and the science is to monitor it. And I speak to my slides. Although I teach a lot, I never look. So basically, the keywords is landslide and how they are affecting roads and railways and villages and cities and that kind of thing. And James give me the site on bilateral arrangement as he talks to the Indian government and so forth. So now I'm a consultant, but nevertheless, thanks for being here, and thanks for talking to you about my roots. Okay, I'll give you a little bit of a background before we go into the science as usual. Can you see to the back there, young lady? You can see it, are you? My eyes, I'm here, I can't see something. That's why, probably should bring my glass. So that's why I highlight in red, so at least from a lecture standpoint, this is your take home, so to speak. You don't have to read everything. Since 1988, ISRO, which is the Indian Space Agency, it's very big. It's run by Modi. He holds it close to him because it is a big deal in India. ISRO has launched many, many satellites. And these satellites are used for many things: agriculture, water resources, planning, mineral exploration, monitoring, and so forth. But there's a but. All their satellites are using the sun. So it's like Google image. When the sun is on, you can take an image of the area. But nighttime, you cannot take an image. In Canada, we are very good on radar because the radar can take an image day and night. I don't want to go into the science, but it's like a flashlight. You put a microwave signal and you can see down to the earth. Sorry, I'm going to 101 physics here, but that's just to give you an idea. So, so it's like a flashlight from space, and therefore you can light up your target at nighttime, daytime, when the clouds are on, it passes through the clouds and so forth. And we're good at this. We're very good at this in Canada. we are what, 40 years we've been in this business, and people like me are part of the committee. Okay, so let's continue here. So the Indian satellites are used for many, many things, and this is important. India is one of the largest, has one of the largest constellation of remote sensing. So satellites are a big deal over there. And they put it up in space. Now, you know, they're going to the moon. So they're very, very smart and big, big industry in space. Equivalent eye to eye with anyone in the world. So it's a big deal over there. And where we come in, let's go back, I tend to go on and on. In April 2012, ISRO launched a radar satellite. So they're catching up in a big way. Not only their optical satellite, but a radar satellite. But this satellite was not good enough, you know, in the orbit of it, to measure centimeter motion that James talked about. Ours were good enough to do that. So they had to do a lot more work. So what they did is said, okay, Canada, okay, James and Vern, come and teach us how we can use it. And that's the origin of this project. India wants to obtain the technology to monitor their hazardous area at centimeter motion because they don't have the know-how yet. Because in order for you to have your satellite has to be in this orbit tube, there's many things, I don't want to go into it. It has to be very sophisticated. So it was called RISAT. Radar Satellite 1. And then the RISAT now, it did not have the capabilities, that's what it's saying. But India has earthquakes, you know, geophysics, a lot of earthquakes, seismic folks, a lot of landslide, and so forth. So they need to use this as a technology of monitoring. Now, let's be careful. They're doing a lot of work monitoring, but they need an additional technology to do modeling. Okay, that's where folks like scientists and us work. So that's where the part. Now, the project aimed at monitoring infrastructure and landslide and the people who are doing the monitoring is not only ISRO, it's a geologist, Geological Survey of India, where you have the seismologist and all those folks. So the memo, the cooperation was not with ISRO per se, because those are space scientists. It's with the Geological Survey of India and folks like us, the Geological Survey of Canada, where the scientists meet. So we don't need ISRO, we don't need NASA, we need geologists and geologists. So that's what this project was all about. Now, an important thing, this year, I don't know when, Jim, in about 2 years, 2 months or 3 months, JPL, the Jet Propulsion Lab, NASA, out of California, and India are going to launch a very, very sophisticated radar satellite. So the Indian Americans, they're hugging one another in a big way. Pardon my term, hugging. But I teach a lot, so I know these simple terms. You know, they're really doing good science between NASA and India. And they're launching this very, very sophisticated radar satellite. Next one. Okay, more of the background. I want you got to do the 101 first before I show you some imagery. Radar system, I already talked, it's an active system, not like the sunlight. It's like a flashlight in space. Okay? Microwave flashlight for the term. And the radar sees through clouds and day and night imagery. The radar can be mounted in airplanes or in an orbit tube with a satellite. And I did mention that Canada, we're a big name in radar. We do this a lot. I'm one of the products of it. Now, all this is telling you, this is a little bit more detailed. This is the radar image. And the satellite, if I'm the satellite, I'm treating like students again, sorry. This is my satellite and it's going around the world. It always looks to the side, never looks down. Some satellite looks down. This one look to the side. So it goes and takes an angle, 10 degrees, 20 degrees, 30 degrees. So that's how. So radar sat 1, which we launched in 95.
96, 95.
Yeah, I was a kid then anyway. And radar sat 2, and now radar sat 3. I'm the chief scientist of this. So I was happy to leave the government when everything works. So I'd give my bit to Canada, and as chief scientist, this is a constellation of 3 satellites. So the one we did in collaboration with India was the RadarSat 2. And the RadarSat 3, which was launched in 2000, and that's me. I think I'm wearing the same clothes. I'm so sorry. Oh, I did have a white shirt then, so maybe it's dirty, I don't know. This was 2019, and that's the satellite. The last day on, what my son, when I was showing him, he says, Dad, you should put the last day on Earth. I thought that was neat. That's the last day on Earth of the satellite. Okay. Just to give you the 101 of how these satellites work. I move around the lecture room, and I do this a lot, so pardon. Our satellite, like most satellites, in this case the radar satellite of Canada, we use it for ice, big Canada North. We watch the ice, we watch the type of ice, we watch how it breaks up, we monitor it all because it's big in Canada. You can't do anything but look at the Arctic because in Canada, our scientists of the Arctic is very, very huge. So ice, oil pollution, our satellite, winds, how fast they go, ecosystem, forestry, anything to do with the land, crops, soil, oceans, floods, and science. INSAR, excuse me, I'm still have a little bit of a 1 week old. INSAR is what I'm going to talk about. Okay, so INSAR is the way, without going to a big deal, it's the way how we watch the land move. Like we send a beam from space, and if it hits that point on the ground, and if it moves a little, the other beam, we can calculate that difference. Folks like us, we developed the science to do the calculation. So if your land is moving in the Himalayas or the Rockies, we can calculate it. So it's very sophisticated. Okay. So that's the 101. Thank you so much, honey, madam. Okay, another highlights, 101 again. This is what James talked about, but I'll just quickly. Natural resource and India signed an MOU, in this case advanced radar for infrastructure. The MOU is to train GSI, Geological Survey of India staff. And the MOU, we take from our satellites 20 images of the Himalayas. What does that mean? Every month we watch the Himalayas, January, February, March, so 20 images over a year and a half, 2 year period. And then we analyze those imagery and we help the Indians say, is that landslide moving? And is it moving on the city or, those kinds of things. So that's the essence of what we do. We use Canadian radar over a year and a half, 2 year period, over a part of the Himalayas. We train the Indian scientists and we show them how to do it, and we talk about whether this thing works or not. And if it works, they'll apply it. That's the end game, okay? And it worked and it did apply, so that's the end game. And so 20 radar sat, and what we found out, I'm giving the results, so after this you can leave. We found that the landslides are moving from 2 to 5 centimeters, very, very little, over time. And just to give you an indication, some of the scientists are here, a landslide is like an apple tree. When a lot of apples are on the limb, it goes heavier and heavier and heavier, and then breaks. So a landslide moves little by little. This is how the model is, a scientific model. It move little by little by little, and it just move down. And it buries all the folks. So, what is it today I read? Is it in Congo? There's a big mudslide in the world somewhere. Which one? Yeah, in Africa, that's correct. And Papua New Guinea.
Yeah.
Obviously, that landslide was just waiting to be triggered. And people are living down there. I live in Lalo, and as soon as you wet it a little bit with heavy rainfall, it just flows. That's how most landslides. You can have an earthquake. Anyway, we don't want to go into too much geology here. So we noticed that motion. This way. Make a long story short, we picked two areas in the eastern Himalayas, in the state of Bengal, northeast of Bengal. It's called Darjeeling area, and that's the area. It's a very big tourist area. Some of you probably visited. And we picked two areas. One was landslide in Chibo, and one was Gayabari. Okay, so we picked two areas. We just don't pick it. The Geological Survey of Canada and us, we get together and we decide, and these are the two areas. Okay, we did look at an area in Kannur in Tamil Nadu, with the Geological Survey, but we didn't pick that one. It was a beautiful area, and James, we should have gone there.
We did go there.
Yeah, we did go there. I mean, the food is even better in the north.
Oh, we should have chosen it.
Yeah, right, I know. Oh, well, it's all tea plantations, but it was a simple science, so we want to go to the Himalayas where things are more difficult. In science, you tend to pick difficulty. Now, that's the area in Bengal that we looked at. Lots of tea plantations, and you can see some of these landslides. You can see them. I mean, to the naked eye, you can see it. That's the eastern Himalayas. These are the slopes. Gorgeous country. God's country. It's like our area in the Rockies. Look at those tea. Darjeeling tea. Darjeeling tea, it's one of the world's famous. I mean, you all know this. I don't have to tell you that. My roots in the Caribbean, we always say our rum is the best in the world. Your tea is the best in the world. That's what we claim. And of course, so that's where it comes from. Some of you are not, I'm sure you all know about this. Now look at this. That's why this is so important. It's not only a big tourist area that they need to look at, but look at all these small villages and all these in those slopes. So when you have a landslide, you're talking about hundreds and hundreds of property and home, and so these are on the slopes. So infrastructure, small villages, slums, and so forth. Now I stole this from the web, so in case they said Singhroy stole something, that's from the web. This is also big in tourism. But what's important about, I'm just giving you the 101 of the tourist part here. I'm sorry most of you know this. This is called a toy train. And I'll tell you a little bit about it. So anyway, this is all from the web. It's a big tourist area in the upper Himalaya, in the foothills of the Himalayas. Lots of good food. Anyway, you know it all. Vegetables, fruits, fresh fruits, good restaurants, anyway, it's all there. Now let's get to the science back again. One site, two sites. One is called Chibo, one is called Gayabari. Now let's talk the science of these now. Now I've made the case why. And we were in the field now. And James, he's standing on the sidewalk. It's not that he's a giant. And we were all down here, and James standing on the sidewalk.
I don't remember that.
Yeah, well, you're not that big. We're all the same height. Anyway, so here we are. That's me, that's James, this is Dr. Goat, and these are the local, like mayor and stuff, the important guys in the nearby village. And what they're doing, here's a landslide, And that's the railway. It's blocked the toy train area that's going all the way to the small town. So that just give you a field shot. Remember, we're going to look at that area from space, and that's the idea. Okay, landslide 101. Some landslide, not all landslide. The one I talk in Africa, in what's the name of the place?
Papua New Guinea.
Papua New Guinea. That may be different. This particular landslide is different from the one in Papua New Guinea. This one moves like a spoon. Think of a spoon. If you have the ground like this and it meets the rock, it moves down like a spoon. It does not flow. In geology, we have different way of looking at the earth. This is a different, it's called a retrogressive rock slide. Just say yes, and we'll move on. And the Darjeeling Himalayan Railway is a UNESCO World Heritage Site. That's why it's so important for us to look at it. And Himalayan villages around the railway are affected by these landslides. Big for tea gardens, big for tourism, and that kind of thing. Okay? Now, this is a bird's eye view from one side. I'm so sorry, I'm moving around. The poor guy is trying to.
No problem.
Okay, I'm so sorry for you.
I have a mobile hand.
Yeah, you shouldn't tell you.
So I think that photo, we were standing right on that.
Yeah, we were standing, James and I were standing all over here. We took the picture. Now, what's important, my friends, this is a big deal.
Is that a landslide?
Yes, ma'am.
Oh, okay.
That's how they look. You know, the ground just, millions of tons of rock. Just, this is normal. Just move on villages and panoramic view. But you see this little line here? Can you see it from the back?
Yeah. Yeah.
That's a highway.
Wow.
It's a big deal. And on top here, there's another highway. One there and one there. And folks are living along here, That's where the tea gardens are. That good, nice Georgian tea. That's where they're growing. Now, Dr. Ghosh, the Indian Geological Survey, he's a director now. He's a big wheel now. He mapped the geology. That's a top highway. That's a bottom highway that you see, and that's the where the big landslide. And all he tells you what kind of rocks they are. The reason different geology, different landslide, behave differently. Landslide like people, they have different character. The world, the geology have different character. I'm so sorry, sir. I like to move around.
No problem.
Now, if you're driving on the highway, which James and I, we're driving on that one highway, that's how it looked like. You're driving along, and then you see how the highway is moving downslope. Yeah, I'm so sorry with the poor lady there. Sorry, lady. She's listening. Okay, and so this is just an effects. The reason I put the example, it just shows the effects of land motion on infrastructure. As a geologist, these are physical evidence of what you're going to be mapping and monitoring. And what our plan was is to monitor a whole 20 kilometers of this. But in a satellite, it doesn't look only there, it looks in a large area. Okay, and this is the local villagers. Here they are working along to build botches or walls, basically to keep back the landslide. They have to repair it all the time. Because this highway is the main highway that connects the big tourist area from the Lindor area.
Is that a railroad track?
Yeah, this is a
Railway.
Rohit, that's the, it's interesting, they call it toy train. And it's only 2 feet, James. It's only 2 feet. The British, I think, built it way back in forever time, whenever they were there. 18, I don't know, for?
1800.
1800. So it was a toy train that the British built and Indians inherited. I hope I get this right. And it takes tourists and folks all the way up, the Himalayas, and nice little small towns and gorgeous markets and all the things up there. Good ice cream and everything is up there. It's gorgeous. So we took it there, and the landslide is going to block that. So the toy train business is going to be over for 3 months until they repair it all. So, and these villagers, they live over there, and the kids are helping mom and dad. Anyway, it's lots of stuff is going on. And now, this is where the science comes in. Now listen carefully, grade 9 students now. If you're sending a beam from space to look at landslide, and we're only looking at centimeter motion, and there are a lot of trees there, so the leaves and the trees are moving, if the wind and so forth. So the movement of the leaves and the trees is bigger than the ground. So we, as scientists, have to filter that out in order to correct motion. So we designed something they call a corner reflector. And a corner reflector is like a mirror. If you plant the mirror on the ground and the satellite beam hits the mirror, you get the motion on the ground. And it's not affected by the vegetation. So that's how we do the science. We put mirrors, what is called a corner reflector. I'm not going to give you a test on this, sorry. We got a corner reflector on the ground all over the slope, and we watch the beam hits the corner reflector, and then we measure that from space. And guess who was doing all the work? Yours truly. He went with his was it
Power drill.
power drill, and he was showing all these Indian geologists and director generals. They were intrigued with this guy. And there's James, not only a policy guy, there he was a technical man, a builder of corner reflectors. And James, I think you had
Pretty handy.
yeah, you were very good. And I, as usual, was just sitting there licking my ice cream and watching do all the work. So, and you shipped this from Canada, did you not?
Yeah.
Yeah, he did all the hard work. He put it all together, and we showed him how to put it on the ground. Remember, the purpose of this collaboration is to train the Indian Geological Survey on how to do it and how to install all the field equipment. So there's James doing his work, and this is collaboration in real time. You taking a picture of that?
Why not?
Okay, you did. Okay, and what we did, friends, with the Geological Survey of India, we installed 5 of them. So the satellite imagery from space, we're going to monitor that motion of this this landslide. Where there are folks on there, there may be 1,000 folks are living up there, and some of them along that big highway and the second highway. Remember, there are 2 big highways it's affecting. It's cutting off all the tourism. And here the Geological Survey of India geologist, we sent reflectors for him to install. Okay? So he's installed on the site. And this is again, scientists have to talk about science. It's only one slide though. This is how we process the imagery from space. It's called time series, like January, February, March, April. We look at all the images, and we do the image processing, and then we come up with the motion map. That's all just show that this is the process of how we do this. Now, this is the results. Okay? Now let me explain that to you. Over the 20 imagery from space, if this is times 0, which is September of 2016 to February of 2018, all that's showing you is a landslide is moving slowly, slowly, slowly down. based on the corner reflector data. Okay? So that's our result from space. Using the corner reflector, you're looking at the radar beam on the reflector you put in the field. The reflector is moving down and down and down. And that's we show from our image analysis. Now, all the area in red are the dangerous area from space that we measure. Now, the question is, why is it moving? And when a monsoon falls, when a monsoon rain comes, there is a correlation of how the land moves with all the wet ground, which makes sense. So we're able to correlate the movement of the landslide and on those big highways with moisture. Now this is my interpretation, a simple interpretation from this audience. Clearly the landslides are moving and we could detect it from space. Clearly there's risk to the two big highways and to the toy train, of course. Clearly the landslides are triggered by monsoon. This is nothing new, but we know that. But it confirms that from a scientific basis. And clearly we were able to pick up other landslide. Okay, you remember the landslide is about 1/4 kilometer wide. But we were able to see all the area over a 20-kilometer area that are moving, which is a big deal here, all the other areas. And one of the things we recommend the Indian government and the geological is to put up more corner reflectors in other areas. Now the other area, which is landslide number 2, which I spent only 2 slides on it, it's called the Chibo area. And the Chibo landslide have some rainfall, dense vegetation, lots of tourism, and many infrastructure is planned on area number 2. And what we found is that the areas in red is where we picked up lots of the land moving from space, which has been confirmed with field information. And here is our graph that shows that. The landslide is very, very active. But you know what's important? And I worry about this even today. Let's go back one. I worry about this particular slide, and I hope it doesn't. You know, look at this slope. That's about 4 kilometers. You know, not about 2 kilometers in the sense of slide. There's a lot of small houses, tea plantations. A lot of folks are living small. I worry about that thing just failing one day. Like what we have in New Guinea. If you have a heavy, heavy rainfall, that slope would fail. It would fail. By fail, it means it would slide. And the Indian government knows this. I mean, what can they do? I mean, people are living there. They can't just tell them to leave. You're talking about 4,000 or 5,000. Anyway, it's a huge problem. The slide is very active. Lots of motion on the slide area number 2 that we detect from space. And the Indian government are looking into this, you know. Now, what's the take-home message in all this? Is that we look at a larger area over 20 kilometers. And all the area in red on this eastern Himalayas are the risk areas that we are going to pick out from space using this particular technique. I think I have one more slide. What are we doing for the future? We train, okay. We want to look from a science, you know, like I said, the viewing angle of these, we have to look at these areas in different geometry so that we can get more thorough, more comprehensive information. We haven't done that in this particular example, but we need to look at that. The Indian government is going to look at that with their new satellite. We need more high resolution topography to get even better accuracy. We need to get the Indian government to buy more corner reflectors all over to help with their seismic data. We need to apply these techniques. The Indian government knows this, so these are some of their examples. we need to apply these landslide techniques to seismic techniques. I mean, there's a lot of seismic modeling, but although we look at for landslide, we could for other geohazards. But it needs to be integrated with field work and modeling from the geohazard side. And they integrate this, which is fine, integrate the satellite monitoring with other geohazard assessment. And this is what collaboration looks like. It's in our lab at 580 Boot Street. This tall man was not in the slide, he was in his office. He probably took the picture. And here is one of our scientists, Dr. Lee, Dr. Ika from India, myself, Kevin Murnahan, and Dr. Das. So we have 2 scientists from India, and some of our research scientists, including myself. And this is what collaboration looked like in the laboratory. This is where the things are happening, beyond the politics and the policy and so forth. This is where scientists meet scientists to produce important information to save lives.
We spent about 2 months, I think,
Oh yeah, they were here for
2 or 3 months.
2 or 3 months. And there was one more slide that he puts there when he said, I like to thank Vern because I actually cook him a good curry. And he tells him my curry is as good as his wife. So I felt very good about that. Anyway, so my friends, that's my message.